In today's lecture, we're going to be looking at how to get in and do some measurements and change some surfaces and everything of LiDAR data. Now, so the data that I want you guys to access is in my O drive. So you're going to have to access the O drive, and then you'll go to Student. Wait for it to be nice and slow. And then you're going to go to Construction, Instructors. You're going to find me, which is Karina Butterworth. You're going to go into my shared data folder, and you're going to find Winter 21, and then you'll find SAIT LiDAR. So that's the O drive, Student, Construction, Instructors, Karina, Shared Data, and W21. So W21 stands for Winter 21. So you're going to need this entire folder. You need to copy and paste it over to your own folder onto like your D drive or something like that. And if you do it on the SAIT computers, that's great. So, but it needs to be copied and pasted over, because if you leave it on the O drive, it's not going to let you do anything. And I don't know how many times I tell students that, and I still don't have them do that. So if you right click, I'm just going to show the process of doing this so that you guys go through it. And then you're going to say copy, and then you're going to make a folder in your own area on your own computer, and you're going to say paste. It will take a little while for it to come over, but that is what I need you to do. So then your next step is to open up ArcMap, not ArcGIS, ArcMap. So you might have, I think it's 10.6 that's on the SAIT computer, so you might have a version less than me, and that's okay because everything works exactly the same. I really haven't figured out the difference between 10.6 and 10.7 when it comes to any of the stuff that I do, so I think it's just more like improvements in the model builders and stuff. But it needs to be ArcMap. If you are opening ArcGIS Pro, it is going to be the wrong software. Now, my computer takes a few minutes to load, so I know that you guys have just used Arc Pro for GIS. So you're going to be very familiar with that. So this one's just a little bit more broken down into, into smaller steps and a little bit more repetitive steps, but you do need to do that. So I'm just going to talk about the data set while I'm waiting for ArcGIS to open. So in the data set, you're going to have a data overview. You're going to have overview with roads. You're going to have LAS files, and you're going to have data specifications. So the cool thing about the data specification sheet is that it does tell you some of the information that we've already covered in our class. So for example, the flying height, this was above mean sea level. Above ground was between 450 to 500 meters, so we know how high it was. We know the speed. We know the field of view and the pattern that it was taking it in. So it was taking a triangle pattern. So that would have been an oscillating mirror. And then there's an image that they do take, which is not included here in our data set, but it has a resolution of 5 to 6 centimeters. Then we have our pulse rate. So there's our pulse repetition in hertz. So I'll let you do the math on that to figure that out. The maximum scan rate was 50.2 hertz, which is, so there's the pulse rate and then the scan rate. So this is it going back and forth. This is the actual pulses itself. And then the width itself on the ground is translated to 414 meters. The point density is on average 18.05 points per square meter. And at the nadir, it is 16.27 points per square meter. These are estimated accuracies, so these you can't really take them as is, but you can take them as like general statements. These are already the observation error model. These are what those are calculated through. So they don't, going past that, we don't really have any other information like specific to local areas rather than that. And so this is also a bar or a threshold that you would want to aim for when you are doing your models. So it also goes through what the scanner looks like, the different pieces that go with it, and then a lot of information on the scanner, how it was assembled, different pieces of the product, how was it created, etc. So these data sheets are really important to help you out with understanding what is it showing me, how much information am I going to get, and you can also use it to do some accuracy calculations later. So these last files, I don't suggest double clicking them because they try to open them up in, they used to try to open them up in, I think, Socket. And then Socket would make like 5 files, and then you would end up like with 4 times the amount of data and data space that these files are. So we don't want that. So, all right, so, whoops. So I don't have my thing on the right screen here, but when your ArcMap opens up, I just want you to say New Map and then a blank map and press OK. So I couldn't show that because it wouldn't let me move this over for you, but that's what it did. So here we're at a new map. So the first thing we're going to do is create a last data set. So I'm going to connect to my folder because I can see that I'm not connected to the right folder. And so I'm going to connect to folder. I'm going to find where I saved my data for this class. And I'm going to make sure that it's one folder up, right? Because I have my folder here. I want to make sure it's in the project folder. And then it connects to the folder here. And now I'm going to have all of my last files in here. Just wait for it to refresh. There we go, so that you can see the last files. Now, when I click on these, I'm right-clicking, by the way. You can double-click as well. If you double-click them, the same thing comes up. We can see file information, so it tells me how many points are in there. It tells me the point spacing, so we're looking at 17 centimeters for this one. We can see the highest point and the lowest point within that particular file. I can also go to statistics for that particular file, and I can see how many returns that we have and how many points within that file have that many returns. The minimum and maximum values for each of these. And then we can also see like the last, how many had what we would classify as last return, and then how many had just one return, like a single return, and then how many had first of many and how many had a last of many. And these are just different ways to define our data sets, and then the total, of course, at the bottom. Here on the attributes, we have the number of returns, so minimum and maximum. We have the intensity, right, our digital numbers from 0 to 255. We code them from 1 to 7, so there is a standard for classifying your LiDAR data, and it goes up to 15, so this one, it only goes up to 7. We can see our scan angles, so what are of the field of view, and these are just other classifications here. So you can see here's my 3 classifications for this data set. We have unassigned, we have ground, and we have noise. So the unassigned category is actually quite large in our case, so we're going to spend a lot of time trying to figure out what is actually showing in that data set. So that's how you can go through and look at all of your last files. But what we want to do is to create a last data set. So we're going to right-click on the folder that you want to put it in. We're going to go to New. If you go all the way down to the bottom, you're going to see Last Data Set. And it's going to create itself here. Then when I see that, I can right-click and I can go to Properties, or you can double-click it. Then we go to Files, and we're going to Add Files. So what we're doing here is we're now finding the last files that we have saved on our computer. And you can highlight all of them because we're going to import all of them, and press Open, and they all should fill in. And you should see this information here. And if you go to statistics, you see all the data. So this is showing you the first returns and everything, and all the Z max and Z min. So we go down here, you can see the minimum value is 980 meters and the max is 1,334 meters. And the percentage that's being in each of these, for example. So we see 1% or 0.01% of our data is noise. So then at this point, we're going to check the coordinate system, and it should be NAD83 3TM 114. If it is not, you'll have to search it out under projected coordinate system, national grids, and then Canada. But that's the one that it is in. The Z coordinate system we'll just leave as is. So we're going to hit apply because we want all of these to be here. And the statistics have been updated, so they're full here. Go to General, making sure that this is filled in. I'm going to store relative path names to the data source, which means that as long as I have my folder, like so I have this ALS folder for myself, this last data set and this folder are tied together within that. It doesn't care what the rest of the file path is. So I'm going to hit apply, I'm going to press OK, add this new data set. So now I'm going to rename this data set because new last data set doesn't help me at all. And I'm going to just call this my airborne LiDAR or airborne laser scanning project. So now I can just drag and drop this over and I get these 4 squares. It shows me all this information with point elevations, but you see nothing. So each of these is a LAS file. And so in order to see it, you have to zoom in. And there it is. So there's my SATE. So you'll see that as you zoom out, the more you zoom out, the less likely the points are going to show, because it's just trying to render too many points to be able to show the entire the entire data set. So here's the Aldred with its bacon top. Here's the Thomas Riley. And here's Senator Burns. So we can see how the heights are all separated out. Now this is great because it's showing us elevations, but there are other ways for us to view our data sets. So I'm going to right click on the gray area above the window, there we go, in the menu bar, and I'm going to find last data set. So here's my last data set, and right now it is not loading. So what we're going to do now is we're going to right click this and we're going to check properties. And I want to make sure that my statistics are up to date. So I'm going to force recalculate them. This may cause it to regenerate. And there we go. All right. So now, so as we zoom out, you can zoom around and see what is all there. So you can see how going down to the bottom of the hill, you can see different points within here. A lot of our focus is going to be at the SATE campus. So we're going to be looking kind of in this area here. And see SATE campus. Then I'm going to go up to I need to set a customize, and then you're going to go to extensions. So customize extensions. And we want 3D Analyst turned on and Spatial Analyst. Those are the 2 extensions that we're going to be using in this class. So you have to put little check marks beside those 2. Press close, and there we go. That's what I was missing. So now you can see that the last data set shows up here. So there's a lot of fun things that we can do with this, along with this like little menu here. So I can change my options. So if I want to pan in different directions, that's fine. Here's just a way that you can do it manually rather than with a mouse. profile tools, it shows me how many points it'll allow in my profile. So of course, the more points you add to it, the longer it takes to generate. Then we can go over here, and this one right now is showing me that I am showing elevation. So what if I click class? So now I can see what is considered unassigned. So we can see a lot of the buildings are gray and they're considered unassigned. We can also see little clouds of gray that are along the ground. I bet you that is vegetation, right? Because it's not necessarily ground. And then we have some noise points. If we look carefully, we can see a couple noise points. Those probably, looking at where they're located, they're probably multipath from the buildings. So that is our class, and you can play around with that. You can see how we have some gaps, right? We were talking about some shadowing that may happen. And then we can also check on return. So here it tells me how many returns I have. Obviously, it's a little bit more difficult to see the buildings because they're the same as like flat ground, but we can definitely make out possibly vegetation. You can see how multiple returns, we can have up to 3 returns for some of these locations in here. So those are the most likely trees. And we can see some lines along here, which are most likely trees, right? So we can take that as key for visualization. And we can go over here, we can see that there's actually like bigger clusters of trees, and that's just right on the edge of my data there. So I'm going to go back to elevation because that one's a little bit more interesting to look at. The next thing I can do is an elevation surface model. So this takes a little bit, it processes it slowly, and it creates a tin. So we can see a 2-dimensional model of our elevations here. And it has to render every time you move, so it takes a little bit while, and then you can see it building that tin, right? Like all as it's moving along. So you can see vehicles that are along the street, all kinds of fun stuff. So sometimes people really like that. But as you zoom in, for example, you can see that, how do I tell the edge of a building here? You see how it regenerates? Is this the corner or is this the corner? What's going on in here, right? So the edges of buildings are sometimes very difficult to define, and this is why we were talking about how the edges are often like just trying to figure out the outline of a building is so challenging. Then I can also do aspect. So aspect is really interesting because it is telling me the angle to the sun, or like to north-south, in which these are pointing. So we can see, for example, like west and east, here's the bacon top roof of the Eldred. See how that changes? Why don't we go down to the soccer field and check that out? So there, and then we come down here, and this is the soccer field. Look at how it actually slopes. So we can actually see a slope on this soccer field. Like this one's pointing south. It has a line down the center which defines which is like heading to the west and what is heading to the east. And why do we do that? For drainage. So that is why that's pointing that way. So the soccer field is not necessarily flat. It actually does have a little bit of a slope to it. And so we can see that with the aspect. And then I can go to slope. And the funny thing is yes, there's still a slope here, but it's very, very small. We can see it's less than 2 degrees. That's why we don't notice it with our eyes. But we can define edges of buildings much easier. So we can see, if we go up here, of course you can see every time I move around that it has to regenerate the tin. But you can see the edges of this building. Like it's much easier to see the edges when you are defining it by slope, because that's going up to 90. So we hope that in the end, when we do our processing with our rasters, we hope that our buildings are all showing at 90 degrees as well. We also do contours, so we can set contours like this. Again, this just chooses its own. You can set some options elsewhere in like other properties. We're going to be building our own contours with like actual set parameters. But you can see how noisy these are as is, right? Like we were showing that previous in my lecture about how like bumpy the contours get with LiDAR. This is just taking it like straight as is and doing that. So that's why we don't use this particular contour option for my class. Another thing we can do is filters. So right now we have all turned on. Actually, I'm going to switch this back to that. We have all turned on, but I can filter this so that it's just showing ground. Now this shows me where, like, empty spots where my buildings are. Possibly some cars over here. Something's going on over there. Then I can say, show me non-ground. So now it's showing me all the points that are not on the ground. So this is anything that classified as that. I can also say which ones have the first return and tell me the elevation based on that. So these filters are really helpful in being able to determine that information. The next thing that we have is a profile view. So if you click the profile view, and let's say we wanted to go from here to here. I'm going to just take a selection of points. So you have to like click, you're going to left click. You have to take enough points to be able to show this, and you have to give like a little bit of width to that line. And here's my profile. So I can see where each building is. I can see the profile of the building, and I can do all kinds of neat stuff with this. So for example, in your first part of your assignment, you have to measure. So there's a measuring tool, and I can take a measurement from here to the ground, and over here it tells me that what the elevation is and what the difference is. So I know that the height is 12 meters, but I know that the top of the building is at 1100 meters. So the measure tool, I can also measure the building itself if I wanted to just measure the width, because now I have an actual line, right? So this is telling me the elevation, but it doesn't tell me the distance. So the reason why is because it's in a profile, which that makes sense. So that's really the key. This one's for profiling. I can close that. I can also do a 3D view. So there's my 3D view of what I have in this entire window here. So it shows everything that I have in my viewport at the moment. I can measure from here as well. So you can see that there's a measurement tool. And so once it allows me to, I can say, okay, I'm going to choose a point from here to here, and it's going to draw a straight line across. This one, whoops. Double click, I guess. It tells me the line distance and then the height difference. Okay, so distance and delta. So this one's a little bit easier to get those distances. You can zoom in and zoom out, and that will, but making sure that you're not on a distance. You have to change to your pan. And then let's say I wanted to get the width of this, I could get my measure tool out, and I can go here to here, and it says that it is 19 meters. So that is, you can use those tools there. You can also use the measure tool within ArcGIS. So just going across like that. So a single point, it tells you, if you double click, let's try it again. Double click, and it will save it and tell you the length of that building. If I want an area, I can click on the polygon, and I can draw an area of a building. Obviously, you would do a better job than I am at the moment, trying to get those corners. So here, double click to close it, and it tells me the entire area. It tells me what the perimeter value is, and then the measurement of the last segment. So you can use these measurement tools to determine the values in the table. And trying to think if there's anything else that I need to show you in this class. I think that's everything. So when you go to save this, your last file has already been saved in your folder. So if I go to my Windows Explorer here, I can see this last data set has been saved because it's connected to this folder here. Okay, so just make sure you keep those together. If you wanted to save your ArcMap as is, I could hit save, and I'm going to put it as an MXD file. I'm going to save my MXD file in there, and I'm going to say ALS project. and then save. So then when you go to reopen, it's going to be exactly like this when you reopen, and that is everything. All right, so in next class, I will be showing you the next steps to our project.